Morning, everyone. My name is Avar Almukhtar, Associate Professor in Digital Technologies and Urban Design at Oxford Brookes University in the UK. I'm presenting a short paper on integration of BIM AR workflow for on a live construction site, if you like. And these are my collaborators on the paper as well. So what we are trying to contribute to in this paper, integration of BIM and AR has been long theoretized, so there are lots of literature on the subject itself, and prototypes developed for experiments, for research purposes, etc., but not many have been applied to live construction sites, if you like, for various purposes, whether they are looking at comparing the as-built with as model for progress monitoring, or to detect issues, or for example to have that socio-technical aspect to it. So this is the contribution of the paper, and the question that we are trying to answer is how is BIM AR integration is deployed, used, and experienced on an active construction site. And the reason for that, we wanted to explore and contribute with three different elements, which is how a commercial BIM AI, because there is a difference between the research aspect and commercial aspect, how commercial BIM AI toolchain can be documented, deployed onto an active site, and what are the benefits and challenges that come with that deployment on an active project site, and what would be the practical implications or recommendations for users to take forward. So where we applied it in Oxford, this is the map of Oxford, and the pin there, it's the location of the site or the project. So the project is a student accommodation block, if you like, for Oxford Brookes University, and we had the BIM model that was developed by the architect. It was they were using during the project Construction Cloud, Autodesk Construction Cloud, and BIM 360 at the time. And the application, which is a commercial application, Gamma AR, you might have heard of it, that was utilized by the project team. And the main purpose was how to overlay to detect issues and sync it back to the BIM model. So we applied it to one site. We did observations and interviews with maximum 10 members of different project teams, from the coordinator, engineers, etc. And the site, as you can see, it's located in the heart of Oxford within a conservation area as well. The main contractor, Morgan Sindall, if you have heard of it, and the project was completed last year. So we had the BIM model. So the workflow was, we deployed the BIM model, the live BIM model, which is as modeled, into Gamma AR. We observed project members using Gamma AR on site. Then they were engaged in semi-structured interviews, followed by a short survey to capture their feedback, and then we analyzed the data from these three strands of a qualitative approach, if you like. So the way it worked in terms of how the model was deployed on site, so the first was, it was a BIM model created using Revit and on common data environment, ACC and BIM 360, uploaded onto the cloud, and then synced with Gamma AR. So it was then, with any issues that were detected in Gamma AR, it was synced back to the common data environment, and then issues were logged in the app itself and reported either using a PDF or an Excel sheet. So that was the workflow of deploying it, and this is how it was located on site. So you scan the mesh or the surface, if you like, of a partially built site, and you can then manually coordinate and calibrate based on features such as like a slab edge, for example, or guidelines or markers you can put on site. So by doing this exercise, the opportunities we observed in relation to using live BIM data with AR on a live project site, it was easy to visualize in context. So it was easier for project members and clients to visualize the progress on site. Coordination and communication was one of the key benefits that they highlighted in terms of how they could then, in a very short span of time, they could see designs overlaid onto the live site. And that led them to easily find and check for errors or duplications or discrepancies between the as modeled and the as built, if you like, which led for fewer clarification cycle between project members, which meant more time saving on issues that arise during construction, and stakeholder engagement, because we had, of course, the project has a client, but in this case, the client was the university. Different members from the client side needed to engage with the project, needed to see the progress on frequent basis, so it allowed that to take place in a more meaningful way by overlaying the progress onto the live project itself. And this is one quote from the site engineer. It's easier to understand what you are building when the model is literally on the slab. As it was the progress. It helps to reduce confusion from the drawings. Especially on large projects, when you have hundreds of sets of drawing, you tend to get confused, and you get to that cycle of explaining what does it mean, how does it look like, etc. However, it came with challenges as well. So despite the benefits, they highlighted few challenges that came with that integration. One was the alignment and registration, especially when you aligned it first time manually on site, and then you fed back to the live model, then fed back again, then you had to recalibrate and realign again. Lighting and environment played a role, especially if you were like in an outdoor exposed area in a sunny, whether the glare from the device, from the tablet was an issue. Hardware usability as well, it doesn't work with with all types of hardware, and phones, for example, battery drain and these type of issues as well. Data integration, you needed to prepare the model, set the alignments, the markers, so that takes some time as well. And of course, similar to any other technology, user training and user uptake is a challenge that needs to be considered. But what we can take from that in terms of how we can shape the real use of BIM AR integration is, when you talk about productivity and preparation, it's not about just we need to use the technology. You need to know where to use it. So you need to know how to prepare it. In terms of immersion and practicality, so it's not about being immersed in the technology for the sake of the technology. It's about what practically I need to get out from the technology, what makes it easy to use into daily site routine. In terms of accuracy and effort, it's not about making it accurate. It's about the effort you need to put in for, comparing to conventional methods, and what innovation or disruption are you considering by using this tool, if you like. So how it can improve leadership, how it can improve decision-making in the process of that integration. So to finish off, I know I'm running out of time. So it is about flexibility over being very prescriptive in terms of using conventional methods. The implications that the research suggested for practice is understanding that it's not about precision, it's about engagement. It's understanding about how you can navigate, coordinate spatially complex data on site, and it's about how you can then train a leadership and decision-making process. The last slide is just to show the area of research we are focusing on. So we are working on different European funded and UKR funded research projects in the area of XR, digital twin, and BIM. So if anyone is interested in future collaborations, please do shout. And thank you very much for your time.